Welcome back to the next segment in our randomizer lesson. As you can see, the dice pictured before you have words on them. And these dice are actually dice that you can purchase, that you can write anything you want on them. But it's not uncommon for game dice to have things on the sides other than simple numbers. So today we are going to model an object that is a randomizer specifically that is capable of displaying things other than just simple numbers on the sides. And of course we also want this to be capable of displaying any number of different things. So once again we're going to have a multi-sided die where there could be any number of sides to the dice. Okay, let's get to work. So first we're going to need a new class to work with, and we'll call this a LabeledDie. And as we've done most of the times so far, we'll start with our Java.comments, which we'll say is a LabeledDie is a die which can display any given string as a side and can have any number of sides. Okay, we'll make myself the author for today. You should of course be the author of your own project, and the version number will once again be based on the date, so this will be February 19th, 2015. Alright, now we're ready to begin, and as we've done so many times before, we'll go back to the randomizer interface and we'll simply copy the methods from the randomizer interface to our new class, because we're going to need to implement each one of them. Once again, we will replace the semicolons with curly braces, where we'll be filling in code. And then we'll be ready to start writing our code. Okay, I've got my methods here that are ready for me to fill in. But of course, as we've learned by now, we often are going to start with some instance variables, followed by some constructors, constructor methods. Okay, so what does that look like? Well, let's start by saying that first, in this case, we're going to need to store what's going to be on each side. And what's the proper way to store that information? Well, since the information is a collection of strings, we're going to use a string array to store what is on each face, so we'll call them faces. And then I'm going to need to have my constructor methods. Now, if the person using this LabeledDie just asks for a default LabeledDie, what should be on each side? Well, it should just be a standard 6-sided die. So what does that look like? Well, obviously a constructor needs to be public, and then it also has the name of the class. And because it has no parameters, because it's a default constructor, I can simply start filling in my code. Now what we're going to need to do is we're going to need to create the faces array to store my information. So I'm going to say faces equals new string array, and I'm going to want 6 sides in my array. And then I'm going to proceed to fill each of those sides with a value . And I'm going to use the sort of proper way to convert a number into a string this time, instead of my shortcut, just to demonstrate alternative ways of doing things. I'm going to use the integer class, which has a built-in toString method that can convert a number. Notice it says returns a string object representing the specified integer. So I'm going to take I and add 1 to it, because I want the first face of my die to be labeled 1. And then I'm going to randomize my die. Now, You might ask yourself, are there any ways to shorten this code? Well, let's not forget that when you're creating a new array, there is traditionally a way that you can fill an array with information. You can do something like this. However, you will see quite quickly that that does not work because you are only allowed to do this when you declare an array. So then the question becomes, well, could I actually do that when I declare my variable? And the answer is yes. You can. You can do it just like this. I simply have been discouraging you from doing this initialization of instance variables when you declare them because it's the proper job of the constructor. However, it is allowed, and we're going to leave it that way for, actually no, we'll put it back the other way so you can see the way we've been doing things, but just be aware that there is another way to do it. Okay. Then get possible, oh no, now we're ready for our other constructor because of course we're not usually going to be creating a die with 6 sides and 1 through 6 on the sides, because if we were, we could just use a D6 or a polyhedral D6 die. So now we're going to create a labeled die, and this die is going to have something on each side. So we're going to call our variable set sides. Alright, now at this point, you might be tempted to simply say faces equals set sides. And it would work. However, this creates a very bad precedent because this array, set sides, can be accessed outside of our class, and yet because we've made these two arrays the same thing, I will be changing the information within my class, and whenever possible, the data within your class should be protected. In fact, let's make that very clear by adding something I forgot to put in earlier, which is this information is private. Remember, it's supposed to be sacrosanct. Nothing outside the object should be capable of changing the data within the object without going through a method to access that information. And if I do this, I'm setting up a situation in which that might happen. I could change the set sides array in my main program and alter the data in faces. So instead, what I want to do is say faces is equal to a new string array that has a length of set sides dot length. And I realized I've been using set sides here, but let's refactor that and rename it to set faces, just so that we are using the same variable names here. That's considered best practices. We just add the word set in front of the variable name that we're setting within our constructor. It is not, again, a Java rule. It is just simply considered a best practice. Okay, and then now I'm going to set up a loop to loop through each of my faces. Okay, and say that faces I is equal to set faces I. How is this different than what we did before where we just said faces equals set faces? Well, now we're copying the value of each string into the faces array, creating two separate strings that are independent of each other. And then our final step, of course, is to randomize our die. Alright, now we have to do our get possible outcomes, and this is fairly simple because we could just use the length of the array to determine how many possible outcomes there are. And for get current value, we basically want to have the same thing that we've had before. So we go ahead and we add our new variable, which we're going to call our face up, but I'm going to add the word index to the end. and of course it's an int. This represents which of these faces is showing, but it's an index. When I convert that index into a value, I'm going to want to add 1 to it because people expect their die to have values like 1 through 6, not 0 through 6. But of course, this is just a programming decision. I could have left it as an index if I'd wanted to. Okay, now I'm going to do get current face. Well, what is my get current face going to be? I'm simply going to return my faces array for my face up index. And while we're almost done, all we have to do now is do our randomize. So we're going to say that our face up index is equal to, again, we're going to take the integer value of math.random, which is always between 0 and just less than 1, and we're going to multiply that times faces.length. That becomes our index into our array for which face is going to be showing at any given time. Well, that just leaves us with one last method to write, which is our toString method. So we're going to put in our toString. Okay, so what should our toString look like? Well, we're going to make our toString a little bit more complicated, so we're going to do it on 2 lines and say string s is equal to d plus faces.length plus an equal sign plus, and then we're going to get our current face. And then when we return this, we're going to tack on just a little bit of extra information. We're also going to put on a parentheses followed by the current value. Because when we're displaying this, we have to remember that when we convert it to a string, we want as much information as possible. And so this will show the face, which is a string, followed by the value of the actual die, which is a number. Okay, so now it's time to go back to our dice bag runner. Alright, so what are we going to do in our dice bag runner? Well, first of all, at this time, we're going to be, I'm going to take out some of the comments from the previous version. Okay, we're still going to have a dice array of randomizers, and it is initially filled with null values. We're going to have 3 of them. Then we're going to instantiate a new, and this time we're going to make our first coin. Let's make it a new whoops, not that line, a new polyhedral 12-sided die, just to make things interesting. Okay, so this is a new polyhedral die in the dice array. Okay, but for our second die, we're going to make a new labeled die using the default constructor. So we're going to change this to say labeled die, and as soon as I go over here and save changes, hopefully that's going to fix that error. Did I misspell something? Randomizer equals new. Did I misspell labeled? Let's see. Why are we getting an error here? Type mismatch. Oh, what did we forget? So notice now that it's saying there's a type mismatch. A labeled die is not currently considered a randomizer. And that's because I forgot to add the magic words implements randomizer. I copied the randomizer methods, but if I don't identify it as implementing the randomizer interface, Java doesn't know that those are in fact the same thing. So I'm going to save changes now, and boom, my error went away and I'm ready to go. Okay, then I'm going to go back to my LabeledDie here, and this time, instead of using the default constructor, I'm going to instantiate a LabeledDie using the overloaded constructor. I'm just going to change the tense here. Instantiate a new polyhedral die. Okay. Alright, instantiate, let's spell it correctly. Okay, so how do I do that? Well, first I'm going to need an array, and it has to be a string array, to store what's going to be on each side. So, what am I going to put on my sides? Well, this time I am going to call my array sides instead of faces, just to show you that the arrays are actually different array names but share the same values. And then I'm going to use the shortcut constructor here to make myself some sides. I'm going to have my first side is going to be side 1, then I'm going to have side B just to change things up, then I'm going to have side question mark, then I'm going to have side exclamation mark, and finally I'm going to have side alpha to really mix things up, to emphasize that it's a labeled die, and you can have anything on the labels you want. And then in the constructor here, I'm going to pass this array, which means that Java will call the correct constructor for a labeled die and store each of these values as the sides for that array. And that should be the only thing I have to change. And again, that's because of the magic of polymorphism. Allows the correct methods to be called here when I randomize, and when I get my current value, and when I output my die as a string. So let's see what we get when we run this. Oops, no pointer exception on line 14. Faces. Oh, because I forgot to say string array faces equals new string array 6. I think I had that originally and then deleted it when I was redoing the code, or maybe I just forgot. Nevertheless, easily fixed. You notice that I used this to tell me which line the error was on, to quickly jump to it, figure out what the problem was, and then back to work. Alright, let's see if it works this time. Oh, wow. I wonder if it's the same array but in the other constructor. Faces.length is not working in randomize. And I am not quite sure why. Oh, because I included the type here, and so it made it a local variable. Okay, whoops, 2 errors today. Well, had to happen eventually. Okay, let's try it now. Ah, there we go, much better. So notice my D12 works as expected. I just get rolls between 1 and 12. Then for my default constructor, I get what appears to be a 6-sided die. But notice, because it's a labeled die, it includes the values here, which match what's on the faces. But then for my 5-sided die, because I included 5 labels, so it's a 5-sided die, I have each value, or each face here, and then I see the actual value. And if we add these up, we have 8 plus 3 plus 3 is in fact 14. So we can verify that our code is once again working properly. So after a few little missteps there along the way, a few code corrections, we are back in business. Now, for our next lesson, we're going to see that it would have been possible to create this labeled die with many fewer lines of code using something called extending an object.